Hello viewers, this lecture is based on the factor affecting the rate of reaction. So let's discuss all the factors in detail. So we do have 5 common factors: nature, concentration, surface area, radiation and temperature. First of all, let's discuss our first factor, that is nature of reactant. So basically, at the initial, to understand the nature of the reactant, just suppose that we do have two different compounds, namely NaCl, and at the second side we do have Fe. Now dissolve these both in H2O, the water. What will happen? Basically, the NaCl will dissolve. Apart from that, the Fe, the iron, will not dissolve in the water. Why? Why it is not dissolving? So we're gonna say that the first action that should be that the Fe here basically is not that much observed in the nature. It is so highly bonded, as well as it is a proper element. It is not a compound. So here this Fe will not dissolve, but here NaCl will produce the ions when dissolved in the water. What will happen? Basically, the Na will become Na positive, the metal basically, plus the Cl will become negative, the base in nature. So here, the first thing, I think I should write it. So the first point that we should note that it should be a compound, because a single element cannot produce ions apart from their valency, and they are just having the outermost shell vacant. But here the condition is that for dissolving, for ionization, what should be the first step? It should be the compound. Apart from that, it is stated that ionic bonds, the bonds which produce ions, are more weaker as compared to the covalent one. Why? Why so? If you're going to have a look at the dissolution that we have done, Na plus H2O, that basically makes the ions of the Na positive and Cl negative. Why? Because the bonding between Na and Cl are ionic. Basically, ionic bonds are weak in nature. They do make ions whenever they are attracted towards the positive side and the negative side. If we'll see, the negativity of this hydrogen is 3.5. The electronegativity of the H hydrogen is 2.1. That is again squared. Apart from that, if we're going to have a look on this sodium and chloride, so the electronegativity of the sodium is 0.9, as it is the metal. Metal do have electronegativity less than 1. And the electronegativity of the chlorine is basically 3. So what will happen? Actually, this compound Cl is attracted towards the hydrogen, while the Na is attracted towards the oxygen or hydrogen, the vacant element. That's why if we combine the electronegativity of this compound, let me highlight it. If we compare the electronegativity of H2O with the electronegativity of the NaCl, so which is more electronegative? Of course, the water. The water is more electronegative. That's why it breaks the Na and Cl into ions. That is what called ionic bond. As compared to if we talk about the covalent bond, H2O is a covalent bond with high electronegativity as well as hydrogen are non-metal plus non-metal. Non-metal and non-metal do have high attractive rate as compared to the other compounds. So ionic bonds break fast because of less En, electronegativity. Now this is called the nature. Okay, so let's have a look on its definition. So basically, as we can see here, the rate of reaction is faster in case of more reactive metal than less reactive metal. That means there should be a reaction between a less reactive compound from the more reactive compound. For example, sodium, the metal, they have given the example of the metal basically reacts with the cold water, while calcium does not react with the cold water at all. That basically shows us the nature. The nature of the sodium and the calcium, both are metals. But what is the difference? Because the sodium has electronegativity of what? 0.9. If we compare with the electronegativity of the calcium, so basically the electronegativity of the calcium is 1. What does that mean? That means the bond between and the concentration bond, if we bond it with the CaO as well as NaO, so the bond between the CaO and will be more stronger than the NaO because of the electronegativity. That's how they have explained that it will not react with the cold water very fastly. Why? Because of the electronegativity. As compared to the sodium, it will break faster, it will react faster because its bonding is less. That's the concept behind the nature of the reactants. I hope that you get it.